You're cruising down the road, maybe on your way to work or heading out for a weekend adventure, music playing, everything feeling just right. Then, out of nowhere, that little orange check engine light flickers on. Instantly, your heart sinks and your mind starts racing. What could it be this time? You pull over, grab your trusty code scanner and check the code. Maybe it says something about an oxygen sensor or a catalytic converter. You do your research, buy the part, and spend your afternoon replacing it. After clearing the code, you feel a wave of accomplishment. Problem solved, right? But then, just a few days or even hours later, the light comes back on. It's the same code, the same warning, and the same sinking feeling. Frustration sets in, and you start to wonder if you'll ever get rid of that stubborn light. This endless cycle of scanning, replacing, and hoping is all too familiar for many car owners. It feels like you're stuck in a loop, spending time and money but never really solving the problem. People often shell out hundreds of dollars on new sensors, wiring, or even a brand new catalytic converter, only to see that dreaded light return. The costs add up quickly and it's easy to feel defeated. The real issue? The part you replaced might not have been the root problem at all. Sometimes the code points to a symptom, not the actual cause. The check engine light is just a messenger. It's your car's way of saying, hey, something's not right. But it doesn't always tell you exactly what's wrong or where to look. To truly fix the issue, you need to dig deeper and diagnose the real cause, not just swap out parts and hope for the best. Understanding what's really going on under the hood is the key to breaking the cycle. In this guide, we'll walk you through the most common recurring codes that keep coming back, no matter how many times you clear them or replace parts. Codes like P0037, P0036, and P0420. These codes all relate to your car's emission system, specifically the oxygen sensors and the catalytic converter. These components are crucial for keeping your car running clean and efficiently, but they're also some of the most misunderstood. We'll show you how to go beyond just reading the code. You'll learn how to diagnose the real problem, whether it's a wiring issue, a faulty sensor, or something deeper in the system. With a few simple checks and the right approach, you can save yourself hundreds of dollars and a lot of headaches by fixing the true cause the first time. So grab your tools, clear your schedule, and get ready to finally put an end to that annoying check engine light. We're going to tackle this together, step by step. Ready to break the cycle and take control of your car repairs? Let's get started and make that check engine light a thing of the past. Let's break down what these codes actually mean and why they matter for your car's health. When your check engine light pops on and you see codes like P0036, P0037, or P0420, it can feel overwhelming. But each code is a clue, pointing you toward a specific problem in your vehicle's emission system. P0036 and P0037 both relate to the heater circuit in your downstream oxygen sensor, usually bank 1, sensor 2, which sits after the catalytic converter. The heater circuit is crucial because it helps the sensor reach its operating temperature quickly, even when the engine is cold. This allows the sensor to start monitoring exhaust gases right away, which is essential for keeping emissions low and engine performance high. The heater element inside the sensor gets it hot fast, so it can send accurate data to the engine computer almost immediately after you start the car. Without this quick warm-up, your car would run less efficiently and pollute more during those first few minutes. If the heater circuit is faulty, maybe due to a broken wire, corroded connector, or internal sensor failure, the sensor can't do its job. That means your engine computer won't get the right information about your exhaust gases, which can lead to poor fuel economy, higher emissions, and even engine performance issues. Specifically, P0037 means the ECU is detecting low voltage in the heater circuit. This could be caused by a bad sensor, a broken wire, or even a blown fuse in the car's electrical system. Diagnosing the exact cause is important before replacing any parts. Now, P0420 is a big one. Catalyst system efficiency below threshold. This code means your catalytic converter isn't cleaning up the exhaust gases as well as it should, which can lead to failed emissions tests and increased pollution. Usually this means the catalytic converter is either clogged, contaminated, or simply worn out from age and use. It can't convert harmful gases into less harmful ones effectively anymore. The ECU checks the efficiency of the converter by comparing readings from two oxygen sensors, one before and one after the converter. If the readings are too similar, it means the converter isn't doing its job. If both sensors show nearly identical readings, the catalytic converter isn't reducing emissions as it should, and that's when you get the P0420 code. But here's the catch: a failing converter is often a symptom, not the root cause. Something else like engine misfires, oil leaks, or coolant contamination may have damaged it. So before you rush to replace expensive parts, it's crucial to figure out what caused the problem in the first place. Addressing the underlying issue will save you time, money, and future headaches. Don't just swap out parts, take the time to diagnose the real issue behind the code. That's the key to a lasting repair and a healthy engine. Got a P0037 code? Don't rush to buy a new sensor. The code means the heater circuit isn't working, but the problem could be anywhere: sensor, wiring, connector, or fuse. Think of it like a lamp that won't turn on. Is it the bulb, the plug, or the breaker? If you replace the sensor but the wiring or fuse is bad, the problem stays. The same goes for P0420. The catalytic converter rarely fails on its own. Something else usually causes it. If you don't fix the root cause, you'll just keep replacing parts. Always diagnose the whole system, not just the part the code points to. Otherwise, you're wasting time and money. Be a detective, not just a parts replacer. Let's dig deeper before you spend a dime. Before you rush out to buy a new sensor for a P0036 or P0037 code, it's important to take a step back and do some basic troubleshooting first. Many times, what seems like a faulty sensor is actually a much simpler issue that can be fixed without spending extra money or time. Start with a thorough visual inspection. Carefully look for any damaged, melted, or frayed wires leading to the sensor. Wiring issues are a common cause of these codes, and catching them early can save you a lot of hassle. Next, unplug the sensor's connector and take a close look at the pins. Check for any signs of corrosion, greenish buildup, or bent pins that could prevent a good electrical connection. Even a small amount of corrosion can cause big problems. If you spot minor corrosion, use contact cleaner to gently clean the pins. Also, make sure the weather seal on the connector is intact and not letting in moisture, which can lead to future issues. Once everything looks good, it's time to grab your multimeter. With the sensor unplugged and the key turned to the on position, use your multimeter to check for 12 volts and a solid ground at the harness. This step confirms that the car's wiring is delivering the power the sensor needs to work. If you don't find power at the harness, don't forget to check the fuse related to the sensor circuit. A blown fuse is a quick fix and can often be the root cause of the trouble code. If the wiring and fuse are both in good shape, move on to testing the old sensor's heater circuit for resistance. Use your multimeter to measure across the heater pins. The reading should be low, not open or infinite. An open circuit means the heater is bad. Only after you've confirmed that the wiring, fuse, and power supply are all working should you consider replacing the sensor itself. Swapping parts without checking the basics can lead to wasted time and money. By following these simple diagnostic steps, you can avoid unnecessary repairs and get your car back on the road faster. It's all about working smarter, not harder. Don't skip the basics. Often the simplest checks are the ones that solve the problem. Take your time, diagnose carefully, and you'll save yourself frustration and money in the long run. P0420 doesn't mean your catalytic converter just wore out. It usually got killed by another problem. The main culprits? Engine misfires, burning oil, or running too rich. Misfires send unburned fuel into the exhaust, overheating and melting the converter. Burning oil coats the converter's precious metals, making it useless. A rich mixture from bad injectors or sensors also destroys converters. If you're adding oil between changes or have other engine codes, fix those first. Never replace a converter without solving the underlying engine issue. Otherwise, the new one will fail too. Always address engine health before tackling P0420. The converter is the victim, not the cause. To solve P0420, you need more than a code reader, you need live data. Use an OBD2 scanner to watch the voltage from both oxygen sensors. The upstream sensor should fluctuate, the downstream should be steady. If both sensors' readings match, the converter isn't working. But sometimes the converter is fine. Other issues can trick the ECU. Exhaust leaks between sensors let in air, fooling the system. Use a smoke machine to find leaks in the exhaust or intake. Vacuum leaks can also cause false codes by making the engine run lean. Check fuel trims and look for hidden leaks before condemning the converter. The right tools reveal the real problem. Don't guess. Test. Here's the bottom line. Diagnose the root cause, test before replacing, and maintain your car. Don't let a code push you into buying expensive parts. Always fix the underlying issue, misfires, oil burning, or leaks, before replacing sensors or converters. Use your tool's multimeter, scanner, smoke machine. A little testing saves a lot of money. Stick to regular maintenance and pay attention to changes in your car. Catch problems early to avoid big repairs. Be proactive, not reactive. With the right approach, you'll keep that check engine light off for good. Now go fix it right.